Just 3 decades ago, humanity had no scientific evidence of planets existing beyond our solar system. Fast forward to today, and thanks to remarkable advancements in technology and scientific research, we've discovered over 5,300 exoplanets, alien worlds scattered across the cosmos, waiting to be explored. In the early days of exoplanet discovery, most of the findings were dominated by massive gas giants, similar to Jupiter or Saturn. However, as our observational tools and techniques improved, we began to uncover smaller, rocky planets, some of which bear striking similarities to Earth. To date, scientists have identified more than 50 exoplanets with masses comparable to Earth and over 800 with radii less than half that of our planet. While only a handful of these orbit within the habitable zone of their stars, where conditions might be just right to support life, this is beginning to change. We're now discovering entire planetary systems with multiple potentially habitable worlds, including one remarkably close to us in the cosmic neighborhood. Our Milky Way galaxy is home to countless star systems, many of which are compact and centered around stars similar to our Sun. However, planets orbiting too close to these stars are often scorching hot, making them inhospitable to life as we know it. On the other hand, colder, dimmer stars, such as red dwarfs, have habitable zones that are much closer to the star. One such system is Gliese 667, GJ 667, a fascinating triple-star system located in the constellation of Scorpius, approximately 23 light-years from Earth. This system is particularly noteworthy because it contains the first known example of a low-mass star hosting multiple rocky planets within its habitable zone, often referred to as the Goldilocks zone. Like the famous Alpha Centauri system, Gliese 667 consists of 3 stars, GJ 667a, GJ 667b, and GJ 667c. GJ 667a is a K-type orange-red dwarf, the largest of the 3 stars, with about 73% of the Sun's mass, 76% of its radius, and a visual luminosity of just 12% compared to our Sun. Its companion, GJ 667b, is also a K-type dwarf, slightly smaller, with 69% of the Sun's mass and only 5% of its luminosity. The third star, GJ 667c, is an M-type red dwarf, the smallest and faintest of the trio, with just a third of the Sun's mass and radius, and a luminosity of only 1.4% of the Sun's. Despite its modest size, GJ 667c has proven to be a treasure trove for planetary discoveries. Initially, scientists believed there were only 3 exoplanets orbiting this star, but after revisiting existing data and conducting additional observations, they uncovered evidence of up to 6 planets, with 3 or even 4 of them being potentially habitable super-Earths. But what exactly is a super-Earth? This term refers to planets that are larger than Earth but smaller than gas giants like Jupiter and Saturn. These worlds can be composed of rock, a mix of rock and ice, or even have thick atmospheres that could potentially support life. In the Gliese 667 system, the closest planet to GJ 667c is GJ 667cb, a scorching hot world with a surface temperature of around 200 degrees Celsius 392 degrees Fahrenheit. This planet is about 5.5 times the mass of Earth and orbits its star in just 7 days, making it far too hot to support life as we know it. However, the 3 potentially habitable planets, GJ 667cc, SU, and CF, are located farther from the star, within the habitable zone, and have masses ranging from 1 to 5 times that of Earth. GJ 667cc, in particular, has captured the attention of scientists and enthusiasts alike. Orbiting at the inner edge of the habitable zone, this planet has an Earth similarity index of 0.85, making it one of the most Earth-like exoplanets discovered to date. It receives about 10% less light than Earth does from the Sun, but because most of the light it receives is in the infrared spectrum, it gets roughly the same amount of energy as Earth. This could mean that GJ 667cc has a climate similar to ours, with the potential for liquid water to exist on its surface. However, life on this planet would be vastly different from what we're used to. GJ 667cc is likely tidally locked, meaning one side of the planet perpetually faces the star, while the other side remains in eternal darkness. This could create extreme temperature differences between the 2 hemispheres. though an Earth-like atmosphere might help distribute heat and create more moderate conditions. Living on GJ667cc would come with its own set of challenges. The planet's higher mass means stronger gravity. A person weighing 75 kilograms, 165 pounds, on Earth would weigh around 120 kilograms, 265 pounds. Here. Additionally, the planet's proximity to its host star exposes it to frequent stellar flares and intense bursts of radiation, which could be harmful to any potential life forms. The star's strong magnetic field also causes star spots, which can reduce its energy output by up to 40% for months at a time. Combined with the lack of ultraviolet light emissions, these factors could make it difficult for life as we know it to thrive on GJ667cc. The other potentially habitable planets in the system, GJ667 Su and CF, are located farther from the star and receive less energy, which could make them colder. However, if these planets have thick atmospheres, they could trap heat and maintain temperatures suitable for life. The discovery of multiple habitable planets in a single system is incredibly rare, but Gliese 667c may host up to 4 such worlds. This system is a prime example of how densely packed planetary systems around M-dwarf stars can be, and it hints at the possibility of countless other systems with multiple Earth-like planets waiting to be discovered. M-dwarf stars, like GJ667c, make up more than 70% of the stars in our galaxy, which means the number of potentially habitable planetary systems could be far greater than we once thought. Instead of searching for a single habitable planet among many stars, scientists can now focus on individual stars to find multiple Earth-like candidates. As new and advanced telescopes, such as the James Webb Space Telescope, come online, our ability to explore and understand these distant worlds is growing at an exponential rate. The discovery of systems like Gliese 667c opens up exciting possibilities for the search for life beyond Earth. While the conditions on these planets may be vastly different from what we're used to, they remind us of the incredible diversity of worlds that exist in the universe. Life, if it exists on these planets, would have to adapt to unique challenges, such as fluctuating light levels, high atmospheric pressure, and frequent stellar activity. Yet, as we've seen on Earth, life is remarkably resilient and capable of thriving in even the most extreme environments. As we continue to explore the cosmos, systems like Gliese 667c serve as a reminder of how much we have yet to learn. Which star system would you like to hear about next? Share your thoughts in the comments, and stay tuned for the latest discoveries.